So our next family of functions are the trig functions. Let's start off with a nice y equals sine of x. So this is a nice periodic waveform, and the sine function has the property that, first of all, sine of 0 is 0. That's a handy thing to remember. And also, the sine function is odd. So if I were to calculate what is sine of minus x, I get minus the graph that I was looking at here in purple. Let me put that away for a bit. The sine function has a twin, the cosine function. So if I graph y equals cosine of x, I get a very similar shape, but now we have offset it. It's important to notice that cosine of 0 equals 1, and we have this nice smooth waveform again. It's notable that the cosine function is an even function, so if I put it in a cosine of minus x in red, I get just exactly that same graph again. So the cosine function does not care whether your input is positive or negative, whereas the sine function, if you flip the sign on the input, you end up flipping the sign on the output. So there's a handy definition of even functions and odd functions. One thing to note with these is that Desmos, like a lot of modern computer systems, automatically treats the sine and cosine functions and all the related trig functions using radians. So it's helpful to remember that both the sine and the cosine function are defined in terms of taking an angle. So you can think of that as an angle in a right triangle. And how many radians go into a full circle before we wrap around and we're back at the same angle again? Well, in radians, that number is 2 pi. Pi is a little bit more than 6. Excuse me, 2 pi is a little bit more than 6. Pi is a little bit more than 3. So I can see that I am getting the same function values when I move over by 2 pi. Thank you, Desmos. So sine and cosine are sort of the basic trig functions. There's a total of 6 of them, and the rest are all different fractions involving sine and cosine. So probably the most common of those rational functions is the tangent function. Here that is, and let me clear out those other graphs. You can see it's periodic as well, but this function has vertical asymptotes. The reason that happens is that the tangent function is exactly the same as taking sine of x divided by cosine of x, right? I can overlay that exactly on top of itself. So let's bring up that cosine function again. All of my asymptotes, all the places where this function is just shooting off towards infinity, are exactly the places where the cosine function is 0. So I can see in action that I'm getting into trouble because I am attempting to divide by 0. So as I was saying, sine, cosine, and tangent are probably the most common of these functions. The other 3 are the secant function, the cosecant function, and the cotangent function. So of those, I find cotangent to be the easiest to remember. So y equals cotangent of x, and we get pretty much just the opposite shape of the tangent function. And what's going on there is that the cotangent function is exactly cosine divided by sine. So now, right, I've overlaid it. Those are the same function. So all of these asymptotes are the places where I'm trying to divide by 0 in the sine function. So this 0 crossing here corresponds exactly to the cotangent function shooting off to infinity. The cotangent is a little bit less than tangent, excuse me, less popular than tangent. If you can use one in a situation, you can usually use the other, but it's good to know that it exists. Now let's take a look at the other two of these functions. We will be seeing the secant function. So let's look at y equals secant of x. And here again, we can see those asymptotes. These are the places where I'm dividing by 0. And I've still got my green sine function lit up here. I can tell that it is not the sine function that I'm dividing by. Right? I'm allowed to divide by -1. I should be having asymptotes here. It's actually the cosine function that we're dividing by. So let me put in y equals 1 on cosine of x. And now in blue, I have exactly that secant. So these two functions, secant is equal to 1 on cosine. And we get this cool graph that the secant function comes up and it just touches that cosine function. Same down here as well. Does that make sense? If it doesn't, just skip back a minute and watch it again. So that leaves one more fraction. What is the special name for 1 divided by sine of x, lowercase x? Why, that must be the cosecant function. We usually abbreviate it CSC, like so. And you can see, that this is touching the top and the bottom of those sine function waves. My asymptotes are lining up with those 0 crossings. We'll be seeing the secant function a lot when we get to derivatives. This function helps us understand the behavior of the other trig functions. The cosecant does as well, but it's not as popular. And for right now, that's all that I have to say about that.